All right, another use for the synthetic and using that remainder is something called the factor theorem. And again, the names shouldn't really get you too wound up, but this one has a lot of use. So factor theorem is what we're going to look at on this part of our synthetic division. So, wow, at least they can tell what I'm writing here. I like that. All right, factor theorem. Everything's going to set up the same way. It's just this time the remainder is going to tell us if something is indeed a factor of the problem that we're trying to solve. So, this one, they're going to have us do two things. Show that x minus 2 and x plus 3 are factors of this polynomial. And then, once we prove that that's true, we're also going to complete our factoring. Now, why is synthetic nice in this case? So far, for the most part, the problems that we've dealt with have maybe been 4 terms and done grouping, and it's worked out pretty nice because they've been pretty good to us. This a lot tougher compared to what we've been doing. So let's start out with our first one, x minus 2. Now remember, when it's x minus, we do plus. When it's x plus, we do minus. So whatever this is, we do the opposite. So we're going to put a positive 2 in the box this time. And again, they've got everything in order this time. Fourth, third, second, first, constant. So we can do their coefficients. So fourth coefficient, third coefficient, second coefficient, first coefficient, and constant. Bring down the first term. And again, what we're looking for is what's in this box. Now, where the factor theorem comes in, we want a remainder of 0. If our remainder equals 0, that means whatever we checked out front in the box is indeed a factor of this polynomial. So let's walk through our steps again. Front times bottom, add them up. Front times bottom, add them up. Front times bottom, add them up. And front times bottom, add them up. And it works. So the good thing there, as long as we got a 0 for a remainder, that tells us that in this case, x minus 2 is a factor. Now, right now that leaves us with x minus 2 times 2x to the third plus 11x to the second plus 18x plus 9. Well, we can try and factor what's left here. So normally if we did this one, we would have x minus 2, and like I just said, 2x to the third plus 11x squared plus 18x plus 9. And as long as this isn't a first degree, we would try to factor this part further. So we will. But this time we're just going to do a repeated division. So now they want us to check and see, is x plus 3 a factor? So we're going to put minus 3. Bring down the 2. Draw the line. And we only have to go this far because there was no remainder. So this is the end of our term this time. So walk ourselves through the same steps again. So negative 3 times 2. Add those up. Negative 3 times 5. Add those up. Negative 3 times 3. Add those up. Another 0 means, in this case, x plus 3 is a factor. Now my writing's getting sloppy. All right. So if x plus 3 is a factor, that means the x minus 2 that we had already pulled out, the factor, the x plus 3 that we just checked as a factor, and now again, since this was fourth power, this was third, this is second. So now we've got 2x squared plus 5x plus 3. Now once we get here, whoops, oh, writing all over the place. All right, once we get to that term, anytime we got a quadratic, we got a few choices. We can do ABCs and factor this. We can do quadratic formula and factor this. We might be able to go right to our grouping and make it look like a FOIL problem and solve this. On this one, it just happens that it works out pretty nice that I could factor this into 2x times x, and then I'm going to have a 3 and a 1. And if I put this together, I can go plus and plus. So this multiplication gets me this. Now again, you can solve that with ABCs or however you want to do it, but I just went with the quick method. So right now, we took this thing all the way down. First degree, first degree, first degree, first degree. It's completely factored as far as it can go. So this would be my factorization, complete factorization of what I started with up here, which would have been very tough to do with any kind of grouping for what we've done so far up until this point. Now if you notice, there was an x plus 1 here. Now we didn't know that at the time. They were nice to us and gave us 2 of them to check, but look what could have happened, and we'll change color here just so you can see. I could have checked, and if I was lucky enough to say, oh yeah, I think -1 looks like it might work, don't ask me how I would know that. Watch what happens here. -1 times 2, add those up. -1 times 3, add those up. Yep, there it is. So x plus 1 would be a factor. Now of course we didn't have to do this extra step now because we had already found that over here by ways of factoring that we've done in the past. But now the other nice thing is, this was fourth power, we divided one out, third power, divided one out, second power, divided one out, first power. This part that's left is, that's getting sloppy. This part that's left is 2x plus 3, which was our other term here. Now, you're not always going to get lucky enough just to look at that and go, oh yeah, I know what it should be and do this. You're probably going to go to quadratic or something right here. So, another use, factor theorem, in terms of using synthetic division to do some solutions.